LiDAR has become an essential part of geomorphic analysis of landscapes, since it can provide an accurate image of the bare Earth's surface. It has advantages over the structure for motion method, since structure for motion data includes surface vegetation, whereas LiDAR capture bare Earth data, as shown in these example images.
Collecting LiDAR typically involves hiring a company, and these people are expensive because they need to maintain an airplane, they need to have people, they need to do ground control, and typically the weather doesn't cooperate with us collecting this LiDAR. In Alaska, you need clear days, sunny preferably, no fog, and no snow on the ground. Leaves off if you can, because then you get better ground data. If you have a LiDAR and you only need to do a small area, the one solution is to use the LiDAR on a backpack, and you just mount it onto yourself and you walk around and you make sure all the equipment is running properly, and then you have a small area LiDAR dataset. And that's what we tested.
Frozen debris lobes are landslides in permafrost, many of which are located along the Dalton Highway in the Brooks Range of Alaska. We call them FDLs for short. FDL-A is the largest and the closest to the highway. From our research results, we project that it will hit the highway embankment by 2021. So the Alaska Department of Transportation and Public Facilities realigned the highway in 2018 to buy more time. But what happens when FDL-A hits the old alignment? How will its surface deform? How will the embankment deform? How much debris will it place on the road every year? The LiDAR allows us to conduct a change detection in the area right around the toe of FDL-A and to measure volume change from year to year. And this helps us to provide better estimates to our Department of Transportation for the volume that they should expect that will impact that highway. And this helps not only for FDL-A, but all the other frozen debris lobes that are along the highway as well.
This LiDAR device captures so much detail of a landscape that I didn't even realize was there. I have a lot of fun using the LiDAR data and actually going into the point cloud and figuring out what it all is and what it all means, and which data is phony and which data I need to remove and which data is good. And so yeah, there's a lot of interest in the data, but it's also interesting to work with the data. And that is the old embankment. Over here on the right you can see the extent of the lobe, where it was in July, end of July. And this is the three-dimensional window, so you can turn it around and you can look at all the aspects of it. Over on this upper screen on the right, we see kind of a top-down view of that same data, where you have the embankment nice straight here and the lobe is coming to it. And we can use this profile tool to draw a line through here, and this is the width of the line, so you capture some of that data. And down in the lower window here you can see again the cross section that I just drew. So you have the embankment, you have the grounds are in orange here, and the trees are in green dots. And so basically this whole image is made up of dots. So if you zoom in really far, you can kind of see individual dots, but then it's hard to see anything else. So this is what we use to find erroneous data, and this is the near final result of the LiDAR dataset at this point. The FDLA is such a challenging environment to walk in that even just walking slowly up and down the slopes, it's easy to trip and fall. And that is of course challenging because the machine is expensive and you don't want to destroy it.
Also, we can use the LiDAR in a backpack mode when there are limitations in airspace and we don't need a licensed pilot to operate it. So there are some advantages in keeping your feet on the ground. Once you have the hardware and understand the processing, it just requires a field visit and that time to process the data. And this makes for a relatively simple and cost-effective technique to produce a high-quality digital elevation model. That high resolution allows for an in-depth analysis of the surface. And since we can acquire data every year for the same small area on the ground, we can conduct change detection with a high temporal resolution and really understand what's going on.